Hello everyone, welcome to my channel Nomis Bits. In this video, I am going to give you an overview about second generation computer. So, about working of the second generation computer. So let's start this video. And as we know, in first generation computer, we give input with the help of punch cards. So things are not changed here. We give input to the second generation computer with punch cards, and these punch cards read via card readers. But the only difference is that this punch card encoded in assembly language rather than in machine language. In first generation computer, the punch cards are encoded with machine language, but in second generation computer, the punch cards are encoded in assembly language. Now let's see how was it punch. We punch card by the use of key punch machine, and these it looked like a typewriter. You type characters, and the machine punched hole in the card in a specific column. Each card had 80 columns, and each column represented one character. So, the patterns of hole were like this. For example, 5 might be hole in row 5. C might be combination of holes in row 12 and 13. And program switch. You will end up with a deck of punch cards, each card holding one line of code or data. These were physically fed into a card reader connected to the computer. Detailed overview. This is a diagram of a typical IBM punch card. So it has the columns up to 80, and there are 13 rows. There are 12 rows in a punch card. And we use Holyoke code and or EBCDIC code for punching characters into the punch card. So Holyoke code or EBCDIC code tells us to how to punch a character in the rows or in the column so that it can represent a character. For example, if we want to punch the letter A, we punch row 12 and row 1, which represent a character A according to Holyoke code. So in column 1, we punch row 12, we punch hole in row 12 and hole in row 1. Similarly, for punching the number 1, we use single hole in the corresponding number row. Hence, to represent 1, we punch only in row 1. For punching the space character, we punch no hole at all. Hence, if a column is empty, it's read as a blank. So after this, let's see how the second generation computer work. Before we put deck of punch card, which store programs and data in second generation computer, to execute the program, we first loaded the assembler, which was stored on a magnetic tape into the computer's RAM. Assembler is the program that are used to convert assembly language into machine language. The loading process was initiated by a small program called a bootloader, which was stored in ROM, read-only memory, or hardwired using components like diodes and transistors. Once the assembler was in memory RAM, we fed in our assembly language program via punch cards into the second generation computer, and then the assembler converted the assembly code into the machine code by the help of looking OP code tables that are already fed into computer RAM, which is known as assembler. Hence, the assembler programs reads each instructions, look up the corresponding OP code from tables stored in memory, part of the assembler program that already running in RAM, and generates machine code, which was then executed by the CPU. The computer processes the program and produces output, often printed on paper or outputted to another device. So let me explain what's happening here. So before we put deck of punch card, which store our programs and data in second generation computer, we first load the assembler. So assembler is a small program which was stored on a magnetic tape into the computer RAM. Assembler is the program that are used to convert assembly language into a machine language. So we need to first insert the assembler program uh, in order to convert our assembly language into machine language. So this loading process is initiated by a small program called a bootloader. So this bootloader helps to load the assembly language into our RAM, computer's RAM, and then when assembler was loaded into computer RAM, then we put a deck of punch cards into the computer. Then the assembler reads all this input and changes the assembly code into a machine language, and by the help of looking OP code which was stored in the assembler program, and then it reads the instructions and gives output according to it. So this is the working of a second generation computer. Now let's discuss about limitation of assembler program, and there are two limitations of assembler program. Assembler program made for a particular CPU does not work for another CPU. Hence, different CPU architectures have different instruction sets. For example, an IBM 1401 or PDP-1 has a completely different set of instructions and syntax. Because the assembler program is a set of CPU instructions, it ties up to the CPU ISA, which is known as instruction set architecture. So if an assembler program made for only work on IBM 1401. That same assembly program does not work on different computer, different second generation computer like PDP-1. So yeah, they have different CPU. So the different CPU, that means different architecture, and that means different assembly program. Second generation assembly language and third or fourth generation assembly language were different from each other. They are not same at all. So these are the limitation of assembly program. And yeah, that's it for today. Thank you.